Okay, here we have a pretty straightforward problem. We have 100 grams of mercury at 50 degrees Celsius, and it's poured into a 200-gram glass cup that's at 20 degrees Celsius. And we want to determine the equilibrium temperature. And these, as you can see, I've written down the specific heats for mercury and glass. Now our approach, this is a straightforward calorimetry problem. And what I mean by that is, normally with conservation of energy, which is what calorimetry is, it's just conservation of energy, we'd have delta PE plus delta KE plus delta TE equals 0. Okay. But in this problem, there's no change in potential energy. There's no change in kinetic energy. There's just thermal energy, and the change in thermal energy is going to be 0, but there's still heat exchange. And so the approach we use is to do the sum of the Q's, and we say that adding all these Q's, and remember Q represents the heat, the sum of these Q's has to be 0. And you have as many Q's as you do objects. In this case, we have 2 objects. So when I'm applying this, I'm going to have the Q of mercury plus the Q for the glass, or the cup if you prefer, and that has to equal 0. So now I look at the mercury and I say, okay, what's going on? Is the mercury undergoing a phase change, a temperature change, or will it end up doing both? In this case, it's just going to be a temperature change. So I know my formula is just going to be mc delta T. And same thing for the glass. I know it's just going to undergo a temperature change. Okay, so the mass of mercury, that's 100 grams. Because my specific heats are in kilograms, probably best to just go ahead and convert. Sometimes you may not have to, but we're not going to risk anything here. Let's just go ahead and change it. So this is 0.1 kilograms. Specific heat of mercury is 140. Okay. Temperature change. This is going to be final. And the final is my equilibrium temperature. That's what I'm looking for. Minus the initial temperature, which for the mercury is 50. Oops. The mass of the glass is 200 grams, so I'm going to convert that to kilograms. That's just 0.2 kilograms. Specific heat of glass is 840. Okay. And I'm doing final temperature minus the initial temperature. The initial temperature of the glass is 20. Okay, so now we just multiply everything out. I got to do 0.1 times 140 times T final. So that's going to be 14 times T final minus 0.1 times 140 times 50. So that's 700 plus 0.2 times 840 times T final, which is 168 T final. And then I got to take 0.2 times 840 times 20, which is 3,360. Okay, so I can combine my terms. 14 plus 168 is going to be, what is that, 182? Yes. Minus 700 plus 3,360 is 4,060. Okay. And so then I'm solving for T final. So of course that's 182 T final equals 4,060. T final equals 4,060 divided by 182. And I get 22.3 0.31 degrees Celsius. So that's my answer. Now I want to point out one thing here. The specific heat of glass is given in terms of Kelvin. But this could easily be degrees Celsius because we're multiplying it by temperature change. And remember, a temperature change of 1 degree Celsius is the same as a temperature change of 1 Kelvin. So that this is Kelvin here, it could just as easily be degrees Celsius, and that's why here, when I was setting up the temperature change, I put in the temperatures in terms of degrees Celsius. And that means the final temperature came out in degrees Celsius. And that's all okay because the temperature change of 1 degree Celsius is the same as the temperature change of 1 Kelvin.